Hey kids, welcome to 5-6 Writing Methods. Up until this unit, you wrote all of the code in the main method, but now we're using lots of methods. Why have multiple methods instead of just one? Procedural abstraction allows us to name a block of code as a method and call it whenever we need it, abstracting away the details of how it works. Kids, if you took AP CSP, you remember abstraction is just a fancy way of saying we are taking away all of the details. This is a way for us coders to clean up our code so we're not writing the same blocks over and over and over again. And if you watched any of these videos, kids, you know if you repeat code, inevitably you're going to make mistakes. This allows us to shore up a section of it and call towards that. It is really a powerful thing, and we're going to use it a lot. Abstraction serves to organize our code by function and reduce its complexity and reduce the repetition of code. In addition, it helps us with debugging and maintenance, and changes to that block of code only need to happen in one place. Here are some main reasons to use multiple methods in your program. Again, you organize and reduce complexity, organizing your program into small sections of code by function to reduce its complexity. Divide a problem into its subproblems to solve it one piece at a time. And kids, that is so helpful. Reusing code, avoiding repetition of code. Reuse code by putting it in a method and calling it whenever you need it. Maintainability and debugging. Smaller methods are easier to debug and understand than searching through a large main method. And kids, really the heart of this lesson, if you understand those three things, everything else is pretty easy from here on out. Let's look at an example with lots of repetition of code and create a method to reduce the repetition of that code. If you come down here, kids, I promise I'm not going to sing to you at all. We have our method here, and you see we're printing out a bunch of stuff. This old man, he played one. He played knick-knack on my thumb. With a knick-knack paddywhack, give a dog a bone. Well, this old man came rolling home. This old man, he played two. He played knick-knack on my shoe. With a knick-knack paddywhack, give a dog a bone. Oh, this old man came rolling home. Kids, I'm sure somebody out there will auto-tune that to something a little better. I'm not going to K-pop it here. What we're really looking for is just lines that repeat themselves, kids, and we want it exactly. And if you look, if we come down here, we can see, well, this old man came rolling home is exactly like that one. And this with a knick-knack paddywhack, that's exactly the same. These are close except for these two words on them, and I think we're going to deal with that in the next lesson. Let's see if I'm right. Hey. Did you find some repeated lines of this old man song? You may have noticed the chorus is repeated with a knick-knack paddywhack, give a dog a bone. Well, this old man came rolling home. When you see repeated code, that is a signal for you to make a new method. There are 3 steps for creating and calling a method. 1, object of a class. Declare the object of your class in the main method or from outside the class. The method call. Whenever you want to use the method, call object name.method name. Again, we saw this before. And method definition. Write the method's header and body. And this is like the print. So kids, new instance. This is like a call, and this is like these get methods here. So again, kids, these are just 3 ways we can do it. For example, here's a chorus method definition that we could write for this old man song. And we have our chorus, and we have these 2 sentences in them. Run the following code to see the song this old man prints out. Can you replace the last 2 lines in the second verse in the main method with a call to the chorus method instead? You can also see this code in the Java visualizer by clicking here. I think we can do this without that, kids. Let's just go down here, stretch this out a little. And you can see we have our public class song. We have our chorus, which is our main method. It is set to void, so it's not going to print out until it's called. What's in chorus is with a knick-knack paddywhack, give a dog a bone, and this old man came rolling home. If you see here, we have our other main method here, and this is a song, a new song. And what it's doing is it's printing off this old man. He played one. He played knick-knack on my thumb. And then it's calling to my song chorus. And again, how do we call it? Well, kids, we're doing our object name there. Then we come down here. We're printing off 2, played it with a shoe. And then the thing says, can we replace the last 2 lines, which are these 2 lines right here, kids? And we can, because we see how it did it here, just calling up to chorus. So I think, well, kids, let's just comment this out. And come down here, and if we do my song.chorus, when we go ahead and hit run, we should get that printed off. Let's see if that's right. And as you can see, the last 2 lines are right here. And we can test that by just taking off our comments there. And now I should get that printed off 2 times each. There you go. We got it printed off once, and then we print it off again. So we just printed it off twice. So this is just calling up to whatever method we did, similar to the print method we did earlier in this lesson. Parameters. You may notice more repetition in the song above. What about the lines of each verse? Notice that every word is repeated except for the last one that includes a number in a rhyme such as 1 in thumb and 2 in shoe. Kids, I'm not a good rhymer here, so we're going to be stealing a lot of their stuff. Here's just an example of that right there. We can make methods even more powerful and more abstract by giving them parameters for data that they need to do their job. We can make a method call a verse that takes a number and then rhyme to print out any verse. And as you can see, we have everything here as we did up there, except for the word 1. We're just going to do a different number. And we can call it different numbers as we go down. Same thing down here. You can see shoe, we're just concatenating 2 rhymes. And I think we are going to do this here in a second. We'll run the code to see the song This Old Man print out using the verse and chorus methods. We can use a visualizer if we need it. Can you add a verse 3 that rhymes with knee? Can you add a verse 4 that rhymes with door? Whew. How many verses do you know? Well, kids, I don't know very many, so we're going to not do very many, but we'll see where we're at. Let's take a look at our code here. And it looks like we have our first class song here. Inside that, we have our verse, which is a number and a rhyme. And in here, it's this old man, he played, and it's calling to number and rhyme. And then we come down here to chorus, and it's printing off this chorus here. So verse will print off this plus whatever number and rhyme is. And then we're going to print off the chorus down here whenever we want to. And then we go down to our main little print off here, and we're going to do song, my song. And it's going to equal a new song. And my song, verse 1, is going to be 1 in thumb. So this should print off this old man. He played 1. He played knick-knack on my thumb. And then it'll print my chorus, which is these 2 lines. Then it goes my verse, 2 in shoe. So it should say this old man, he played 2. He played knick-knack on my shoe. 2 of these to print off. And we have to add 3 and 4. And kids, if you remember, it gave us an answer up there. It said we need 1 for the rhyme with 3 and knee, and then 4 rhyme with a door. So we're just going to go up there and steal those, kids, because I am not a good rhymer. So what are we going to do? Well, we're going to go back up to my song. And we're going to go to the verse, and we're going to add some new parameters here. And the new parameters are going to be 3 for the number. And then it's going to be knee for the rhyme. Then we're going to do my song.chorus. And then we're going to do the last one here, which is my song.chorus. reverse. We're going to add some new parameters, and that's going to be 4. And what rhymes with 4? Apparently door. And then we're going to do my song.chorus one more time. Now when I go to print and run, I should get, there we got 4 and door, and then 3 and knee. So you can see that we got the rhyme there. So we, by adding parameters to what we've already been doing, we can make our code a little more customizable. And that takes that abstraction to a whole new level, kids. When you create your own method, the variables you define for it in the method header are called the formal parameters. When you call the method to do its job, you give or pass an argument or actual parameters to it that are then saved in these local parameter variables. When a method is called, the right method definition is found by checking the method signature or header at the top of the method definition to match the method name, the number of arguments, the data types for the arguments, and return types. Here's what that looks like with 2 method calls above. Notice how the parameter variables get new values with every method call. And kids, what we're looking at here is basically every time we append this, our parameters are getting updated and it's going to become something new. Remember, computers can do 2 things. It can store information or it can print it. Well, that's it. Java uses call by value when it passes arguments to methods. This means that a copy of the value in the argument is saved in the parameter variable. If the parameter variable changes its value inside the method, the original value outside the method is not changed. That's one way we don't change it. If you pass in an argument that holds a reference to an object, like a string or a person or a turtle object, a copy of that reference is passed and saved in the parameter variable. The formal parameter and the actual parameter argument are the aliases, both referring to the same object. Java was designed this way to avoid copying large objects from method to method. Remember when we discussed reference aliases with turtle objects who are set equal to one another? And kids, these are just our old friend turtles, Juan and Mia, and they are all the same thing, even though they have different names. So they're all referencing the same thing. That's all it's saying. Advanced topic warning. Although strings are not mutable, the classes that you create will have mutable objects. If the reference parameter is for a mutable object, then the method could change the actual object. However, it is good programming practice to not modify mutable objects that are passed as parameters unless required in the specification. Methods can even access the private data and methods of a parameter that is referenced in an object if the parameter is the same type as the method enclosing the class. Note that strings are immutable objects. They cannot be changed by the method. Only a new changed copy of them can be made. And kids, you should remember that from a while back. Just remember, strings can't be changed. Methods can also return values of any type back to the calling method. The calling method should do something with the return value, like printing it out or saving it to a variable. Remember, it's the only 2 things a computer can do, kids. Try the problem below to practice with a string method that takes a parameter and returns a Boolean value. We'll run the following program, which contains a method called findLetter that takes a letter and a text as a parameter and uses a loop to see if that letter is in the text and returns a true if it is, false otherwise. Set the variables letter and message to a new value in the main method and run it again to try finding a different letter. Then change the code of the findMeLetter method to return how many times it finds the letter in the text. Use a new variable called count. How would the return type change? Let's take a look at our code down here, kids. And as you can see, we have our public class string find. We have a Boolean find letter. It is set to strings, and they're both letter and text. We have Boolean flag, which is set to false. And we're going to make a loop to go through our list here. And as long as we're starting at 0 and we are less than the length of the list, we're going to progress through it. What are we progressing through? Well, we're progressing through the different messages here. Now, if the text substring, and text is just the word down here, and if the substring I, which is the part we're on, and I plus 1, well, then it's true and we're going to return true. And we have some different things to find here. If we come down here, this is what we're actually using here. So our message or our text is going to be apples and oranges. And we're going to be looking for a P. And it's going to say, does it look for a P? So it's just going to look and compare for a P in these. And we do have one, so we should get a true. Let's shrink this down a little here, kids. Save and run. Does it contain a P? That's true. Let's go for something else. Let's try a Z. Save and run. It does not. If we just change the word here to zapples, well, it does contain it. And again, what's this doing here? This is just ignoring upper and lowercase, so it's case sensitive as we go through. So I just want to make that point clear, kids. I don't know if I did that above. So that's what it's doing. Now let's try to add a count towards it, kids. Well, let's go over here underneath our Boolean, and let's just do an int count, and that is just going to be set to 0. Let's go down here and add a counter, so I know that I'm going to have to progress through my count, so it's count plus plus. So if it finds anything, we always want it to add it. And let's do this. Let's go to return count right down here. Now, kids, when I get run, it should return if we found it and the count. Now, let's see if that happens, kids. I think I'm going to get an error, though. Ooh, I did. And if you look, it's saying, hey, ints and booleans, they don't get along. Well, kids, what I'm doing here is I'm trying to find letters yes or no. And what I need to do is I need to change this to an int right here. And on top of that, since I'm no longer returning a boolean, I'm going to comment that out because I don't want to return anything there. Now if I hit save and run, and I'm still back to my zapples here. Let's change this back to A. And let's do P. We should end up with 2 on this one. So let's hit save and run. And you can see we have 2 P's there. So just keep in mind, we have to keep the data types right as we do this. And this is going to become real important on our next problem. We have a programming challenge. Here's another song, The Ants Go Marching In. This is very similar to the Old Man's Song in its repetitive structure. We have a little song here, kids. And you can see it looks pretty close except for changing 1 and 2 here and 3. And this one, it looks like stops at this is suck and thumb. And this is tie and shoe and climb a tree. And it looks like this is all they do is marching down the ground. So we have a bunch of repetitive stuff, but we're also going to have to do some concatenating because I know that we're going to have some different counts here. So this shouldn't be too hard. Print out the Ants Go Marching song and circle repeating parts of the code. Well, we just did that, kids. In the active code window below, create a method or methods that take the parameters to print out the verses. The method should be abstract enough to work with all 3 verses. Use good commenting for your methods that describe the parameters. For the autograder, make sure you create a method called verse that takes 2 parameters. Why 2? Well, kids, we needed 2 words from above. In the main method, create an object of the class and call the method you created in the last step to print out 3 verses of the song. Can you add more? I'm sure we could, but kids, again, I'm just going to stop at 3 here. If you go up here, we don't have much to work on. We pretty much just have our public class and then our main void there. Well, we have our public class up here. And what I need to do is I need to start creating my verses and chorus, because that's really all this is, kids. It's just a verse and a chorus. And I think I am going to just get rid of this here, come down here a little, and I'm going to start my verse. So I'm going to comment this out. We're going to start off on our chorus because, kids, I think that's what gets repeated. I am no band person. I'm sure Mr. Neri is just shaking his head if he listened to this. But we'll try our best with our music terms. Let's create our first method here. It's going to be, remember, public void. And this is going to be our chorus. Make sure you spell that right. And what's this going to be? Well, this is just going to be a string. And for the moment, I'm just going to make that num. And under this one, what do we want to print off? Well, we need some curly Q brackets. We need to come down here. And what we're going to do is we're going to go system.out.println. And this one is going to be the ants go marching in. So I can just copy and paste this one right here. But kids, this isn't technically correct because really I want to change the number there. That's my first parameter, right? So let's add some quotes there. Let's do plus. And then I want num to come in here. And then I'm going to do a plus. And we'll do by. And then we have to do another anytime we see the word 1 there. And that's going to be num. And we should get a quote there. And that should end that right there. And that's printing variables there. That looks pretty good. So again, kids, all I did up here, if you can see the ants go marching in, it's just 1 by 1, 2 by 2, 3 by 3. And then again, we have to make 4 by 4 and what else. So just remember that as we go through. Kids, that's my chorus, right? Let's do the verse. And this is going to be a public void. And this is going to be a verse. Again, make sure you spell it right. We are going to do a 2 with this. Is going to be a string num again. And then we're going to do a string. And this is going to be what it's doing. What's a good variable name for that? We'll call this one action. I don't know. We'll see if that works out right, kids. We're going to do some curly Q's here. And on this one, we're going to do a system. Ooh, we got a print though, kids. System.out.println. And on this one, it's going to be the ants go marching. And we got to do the 1 by 1. So I'm just going to copy this one. And again, kids, we want to take place of the actual numbers there. And we're just going to do num plus, and then num again, and a little semicolon. Well, that's one. If you look, the next one is the little one stops, and we have to do 2 things or actions, kids. So let me just copy and paste this one. We're going to come here. We're going to do another system.println. We're going to copy this in. And again, we're going to do the same thing, kids. And this time, it's not going to be to tie. It's going to be whatever action, right? And I hate that we have a gender there, kids, but what do we know? So I'm just going to do my action. And that means the little one stops too, and whatever parameter we put in, we're going to put the action. As you can tell, we have one more line left. And this is they all go marching to the ground. So on this one, I want this one printed off almost exactly. So system.println. I'm going to do some quotes here. Print this in. And they all go marching to the ground. And that sets up my abstraction, kids, my chorus and my verse. Now what we have to do is we have to print our song off, right? And what are we going to have to do? Well, we're going to create a new song, and it's going to be called Ants. And that's a new song like that. And in this one, we want it to be ants. We want to do chorus. And we want to add, for our first number, 1, right? So we need another quote in there. We're just going to put 1. So ants chorus 1. And let's go down to the second one. Let's just do 1 and then we'll print it out. Ants dot chorus. And actually, kids, to see this better, let's put test 1. And let's do test 2. And one more. Let's do our ants verse. And this one is going to be, again, if we look up here, kids, 1 and thumb. Or suck his thumb is the action. So we're just going to do test 3, though, just to see it. And our other parameter is just going to be a test 4. Don't forget your other little quote there. Let's print this off and see how many spelling errors we get, kids. Oh, we forgot a plus down there. What line is that? 8. So if we go down here, we have some pluses. So num plus plus. We forgot a plus there, kids. I think that's it. Save and run. Oh, we got one more. There, we got 2 more errors there, kids. Let's go up to line 12. I spelled string wrong. S-T-R-I-N-G. And then down on here, we have ant. I'm assuming that's spelled wrong. And chorus. Oh, it's ants instead of ant. There we go. I think that's it, kids. Save and run. And there you go. We get test 1, test 1, test 2, test 2, test 3, test 3, and then test 4. So you can see we have 1, 2, 3, 4, 5 lines here. And you can see we have our chorus, which is going to be this. So we're printing that off once. And then when we go to the second line, you can see we're doing test 2, test 2. So it's replacing the num with test 2. And then we have test 3. So it's replacing num with test 3. And then finally test 4. So let's actually put some real words in here. Let's actually start making this into our song. So we'll do 1, 1 again. And then for our verse, it should be what? 1 again. And then, what is it? Suck his thumb or something like that. Yep, suck his thumb. So we're going to come down here. This will be suck their thumb. We're not putting genders to ants, kids. That's just one chorus. Again, kids, they want us to do a couple of these. I'm just going to comment this out a little. This is going to be 1. This is going to be 2. So we're going to do ants. Well, kids, let's actually copy this up here. Print that right there. Because we can just change 2, 2, 2. And the other one, it's tie their shoe. And that's number 2. Let's go to a 3 here, kids. And 3, 3, 3. And the third one is climb a tree. You go climb a tree. And then they think they wanted us to add a 4th in here. And I'm just going to make this 4, 4, 4. How about just one more? That's all I know that rhymes, kids. Probably not good, but close enough. After that, we have our 2 little curly Q friends hanging out at the end. Ooh, we should comment that to 4 as well, kids. Okay. When I go to run this, I should get all of that printed off. Let's see, kids. And as you can see, kids, as we come down here, we do have our code with 2 arguments for verse 1, verse 2, and verse 3. What's going on here? Let's check out our stuff, see what's going on. That's 2, 2, and 2. Looks pretty good. Just doesn't look like it's catching us, kids. I know this is right, though, because we have our 2 parameters and everything. So if you get this far, I think I will take it, kids. I'll go back and look and see if I'm missing anything, but I am pretty sure I'm not. I'm just pretty sure the auto grader is just not picking up on that word verse. I'm not sure why. We'll see if I come back and fix that, kids. Either way, this is totally acceptable. I'm sure it's something that I'm doing in the naming of this, kids. Again, I went back through. This is everything we needed. So again, if you're getting a little caught up, come talk to me. And when I look through your grades, as long as yours looks like mine, kids, you'll receive credit. Let's move on. Here's our summary, procedural abstraction. Creating methods reduces the complexity and repetition of code. We can name a block of code as a method and then call it whenever we need it, abstracting away the details of how it works. And really, kids, this is going to be on your test, so make sure you memorize it. A programmer breaks down a large problem into smaller subproblems by creating methods to solve each individual subproblem. To write methods, write a method definition, write a method signature like public void chorus, and a method body in the curly brackets, and method calls using an object, the method name and arguments whenever you need to do its job. To call an object's method, you must use the object's name and the dot operator followed by the method name. For example, object.method and then some parentheses. When you call a method, you give or pass an argument or actual parameters to it inside the parentheses. Object method arguments, we're talking about the things inside the parentheses. The arguments are saved in local formal parameter variables that are declared in the method header. For example, public void method, type parameter 1, type parameter 2. So it's just those parameters we're talking about. Values provided in the arguments in a method call need to correspond to the order and type of parameters in the method signature. That means, kids, get your parts right and especially your data types. When an actual parameter is a primitive value, the formal parameter is initialized with a copy of that value. Changes to the formal parameter have no effect on a corresponding actual parameter. So that's data types and primitives, kids. Remember that. Because I'm sure there's going to be some trick question on the exam referencing that. When an actual parameter is a reference to an object, the formal parameter is initialized with a copy of that reference, not a copy of that object. The formal parameter and the actual parameter are then aliases, both referring to the same object. When an actual parameter is a reference to an object, the method or constructor could use this reference to alter the state of the original object. However, it is good programming practice not to modify mutable objects that are passed as parameters unless required in the specifications. And again, kids, remember back to that, strings are immutable. We have an AP practice question here. Consider the following class, which uses instant variables to represent money in the wallets in dollars. Ooh, I like money, kids. The put money in wallet method is intended to increase the dollars in a wallet by the parameter amount and then return updated dollars in the wallet. Which of the following code segments should replace missing code so that the put money in a wallet method works as intended? So we have our public class wallet, we have our instance variable private, which is double dollars, and then we have put money in wallet. And we have some amount there. And what we really need to do is we need to add to that amount. Well, kids, really what we're doing is we're getting this dollars here, and we have to add an amount. And then we got to return said dollars. So if you look here, I know my first variable has to be dollars, and I need to add to it. And the only one that really adds to it and has dollars as the first one is number C here. So this one's right, just backwards. This one just set dollars to amount. It's not adding to it. This one, well, it does do dollars plus amounts. Your amount is returned, not your dollars. So that's why it's wrong. And then down here, amount, that's just backwards again. So it should be C. Yay. Consider the liquid class below. We have two private ints, current temperature and boiling point. We have our method liquid, which has an integer CT and an integer BP, that's boiling point and current temp. Then we're setting our variables to the parameters. Then look, we have a boolean is bullying, and then we have an amount, and then missing code. The isBoiling method is intended to return true if increasing the current temperature by the parameter amount is greater than or equal to the boiling point. Otherwise, it returns false. Which of the following code segments can replace missing code to ensure that isBoiling method works as intended? Well, let's go through these real quick. If the current temperature plus the amount is less than the boiling point, we're going to return false, otherwise true. Well, that sounds right, kids. If amount is greater than current temp, return false, else return current temp. That doesn't even make sense, kids, because we need a boiling point there somewhere. If amount plus current temp is less than or equal to the boiling point, return true, else return false. I think 1 and 3 actually satisfy this, kids. If we come down here, well, we have 1 and 3 right there. I think those satisfy it. Let's see if I'm right. Hey, there we are. Hopefully you found this video helpful, kids. As always, if you have any questions, come see me. Otherwise, I'll see you on the next video. See you later, kids. Bye, bye, bye.